Hello! So the other story today is about relics, plants which were dominated Earth in a very pre-historical time, even long before dinosaurs, and they are still with us. That's, I think, is most amazing. So one of the most interesting among them is a psilotum or whisk fern. So this is a very typical tropical weed. Amazing weed because it has no flowers, only yellow sporangia, actually synangia, because each of these yellow dots has 3 sporangia together. Most remarkable feature of Nitum is it has almost nothing. So it has green photosynthetic stems, but apart from them, they have almost nothing except sporangia. So, most remarkably, this is only vascular plant which has no roots. So if we take it out of the soil, we take one of them out of the soil, we don't see any roots, just the basement of stem, nothing else, covered with some hairs which help plants to make some water, but nothing like roots is present. So that situation is so old that maybe this is a still trace of very early land plants. So psilotum, whisk fern, still didn't change much from the Devonian times when most of land plants had these features. That's number one. Number two is a group which dominated land right after the first land plants. So they are, we call them club mosses and spike mosses. So these are not mosses. These are first or maybe second land plants, like this Hupersia one, and they're still present in our forests, and especially rich, of course, in tropical forests. So most amazing feature of them is this very primitive structure of the vascular system. The stems have just one pipe in the middle and nothing else. So if they have sporangia, this sporangia frequently attached right to the stem. Exactly how it was in this like almost 100 million years ago. So these plants dominated tropical forests, and some of them became large trees. These plants in a Carboniferous time were almost number one in the tropical forests of these periods. But then they start to decline because other plants took over, and these plants start to be smaller, more herbaceous. They start to feel like different ecological niches. And amazing is what happens with these giant tropical trees. 1 second. I'll take it out of the water. So, look here. This is a pot which I took out of the water. And this is a small water plant which typically grow inside the shallow water, develop some leaves, and has no flowers whatsoever. It has spores. And if we take it out of the ground, we find a woody stem. So that's absolutely crazy for the water plant to have woody stem, but these plants have it. It's a squillwort, and squillworts are direct descendants of giant tropical trees of Carboniferous period. They still have wood, but now it's almost useless. So they use it like an anchor to anchor in the ground, so they can grow in a place when waves are frequent, so they will withstand some waves or moving of water in general. But nothing else is useful in their woody stems, which now like that small size and only grow underground. Squillworts. And the last one, the last group is almost crazy as all of them. So these are, well, tongue ferns, Aphioglossoi. So this is one of tongue ferns. It's a tropical Aphioglossoi. Here it develops long hanging leaves, but each leaf is divided in two halves. One half is photosynthetic, and second half, it's now growing, will make spores. So this is a character of these tongue ferns. One of the tongue ferns, almost absolutely non-remarkable, see, it's a very small thing, has a record among all living things. This amazingly tiny little plant has the biggest amount of chromosomes. Normal number of chromosomes in this particular one is 1,500 chromosomes. Well, somehow they made it. Looks like this is, well, the inheritance of the age. The group is so old, then the only way to stabilize genome was to increase number of chromosomes. And, well, imagine how long is a cell division in this group, maybe weeks with such a big number of chromosomes. This is it for relics. Thank you.